Today, not much of slides, rather I'll stick to the tools. And yeah, so, so I would recommend you to go through the file formats. That is the important part before jumping on to reverse engineering. Okay. First, you determine because Githera, OLE debugger, x64 debugger, they are supposed to analyze the executable file formats. They cannot be used to analyze your PDF or document files. So which RE tools to choose? So in front of us, there are 4 to 5 reverse engineering tools. One of them is IDA. Another one is Githera. Another one is x64 debugger, fully debugger. So which one to choose? This we are going to talk first. How to decide which tools to choose in what case. So Ghidra is open source, free of cost. x64 debugger is uh, again open source and free of cost. It is upgrading to new features frequently. OLE debugger is old debugger, but OLE debugger and x64 debugger have more or less same feature. But x60 OLE debugger is not being updated maybe since 2013 or somewhat like that. x64 debugger has many new features. It is now as far as OLE debugger as well. IDA has a free version. It has it mainly it is created for commercial use. It's pretty expensive, but it has some of the best features. Like decompiler is there. It supports many operating system. That is second one. And apart from that, different kind of executable binaries. Now let us, before choosing the tool, let us talk about different executable binaries you see. So again, I'll go back to some previous things, whatever we talked about, slightly a bit more detail. So if you compile a code, what happens? Your instructions are generated, and based on your target architecture, your instructions are generated. Target architecture, which is input to the compiler, and this is wrapped around executable file format, which is uh, decided by the input to the compiler based on the operating system. So it would be for Linux CLF and Windows PE file. So there is a concept known as loader, which has capability of parsing these instructions. Okay, so IDA, uh, uh, there is a loader which has a capability of parsing this executable file formats and extracting the instruction. So all the tools, your IDA, Ghidra, and x64 debugger, they have the capability of parsing this. Okay, so they have the parsers. And for Windows executable, IDA, Ghidra, OLE debugger, and x64 debugger have the parsers or the loader. Okay, so we'll call the parser as loader. And this parser actually extract the instruction and it is passed on to the disassembler. So IDA and all these tools have disassembler. Okay, so now this disassembler are again different for each of the instruction set. Okay, for an example, in case if you have a Windows executable which has ARM instruction, x64 debugger or OLE debugger cannot parse it. Okay. Okay, so some more depth. Uh, so when you compile the program, if the compiler is C++, C, Golang, Rust, Delphi, VB, they are going to generate a code which uh, we are going to call as native instruction. Okay. So native instructions are what are native instruction? Native instructions are something that can directly executed by the processor. So even your ARM has native instruction. Even your x86, which is the 32-bit Intel processor, that also has x86 instruction, and uh, that is also native. And your Intel x64 also is the native instruction. So all these tools are basically they work well with Hydra, x64 debugger, and IDA. So the next other kind of programming language we have with us is the .NET or Java. What happens when you compile a .NET binary or a Java binary? So they do not generate the native instructions. Instead, they generate instructions which are known as intermediate language code. And how they work is basically they are executed with the help of a common language runtime. Okay, so these are passed to another engine known as common language runtime. This is in case of .NET. In case of Java, there is the JVM, Java Virtual Machine. Okay, so these machines, these common language runtime or JVM, so are sorry, they translate the intermediate language instruction to the native instruction and then execute it. Now, there are different kind of disassembler and decompilers. Okay, so IDA, your fully debugger, x64 debugger, and your Hydra support the native instructions. Okay, so uh, any process any executable that has native instruction can be used to uh, analyze these. Okay, so again here, IDA and fully debugger, they do not uh, analyze the ARM based instruction because their disassembler doesn't support. Okay, so basically when you look into a tool, there are two parts. Sorry, I missed that. So there are two parts to it. So one is the loader and another is the disassembler, which is integrated with the decompiler. So loader, it is parses the executable, okay, and the decompiler parses the or analyzes the instructions. So whenever you choose the tool, you need to look into these two things: whether the tool supports which kind of instruction it supports, sorry, which kind of executable it supports, whether it is exe or elf. Second thing you need to see is which kind of disassembler or instruction it supports. Which kind of instruction is supported by the disassembler. Okay, so uh, in case of .NET binaries, as I told, .NET binaries cannot be analyzed by any of these tools. So you require a tool known as dnspy. Okay, so there are some other things. Say suppose instructions are ARM instructions, then Githra and IDA work well. So this is the symbol for Githra. If you don't know, this is a dragon sign. If it is x86 instruction, all the four are going to support. Okay, so this is what I meant in the previous slide. Next is when it comes to the executables. Okay, so here are four things. So I usually ask as a question, uh, which uh, which uh, which ones would be appropriate for each kind of thing. For an example, ELF having x86 instruction. Okay, so ELF, as I told, ELF cannot be supported by uh, your OLE debugger or x64 debugger. So ELF works only with Hydra and IDA. Okay, so that's why this, if there is a ELF file which has x86 instruction, it can be analyzed by both of these. Okay, so there is a P file which is a ARM instruction. So this, where does this kind of P file executable fit into? So we have the embedded version of Windows which would be running on the embedded system, which usually follows the ARM architecture. So in this case, again, since this is a P file, in this P file, okay, OLE debugger and x64 debugger have the parser for P file, but the problem here is OLE debugger and x64 debugger, they do not have the disassembler or ARM. Okay, so only things in this case we are left out with is uh, your Kithra and IDA Pro. So when it is P file with x86 or x64 instruction, so all the four work. Okay, so this is how we choose the tools. Again, there are certain features of tools. For an example, IDA, IDA is commercial, so many things are expensive. IDA decompiler is now free, but it is cloud. So many organizations might not allow because you might end up sending some data to IDA Pro or Express Cloud. Okay, so that is one demerit. IDA has a free version, but it doesn't. Actual free version should not have the decompiler. Now the decompiler is integrated with the cloud, that the free version. Okay? Otherwise, if you want the local decompiler, you have to buy it. Another thing is IDA supports many instruction set and many file formats or executable file formats. IDA has a very good debugger. IDA has a supports kernel debugging in Windows as well. Um, IDA works both on Linux, Windows. So Githra, it has a good decompiler. It is, as I won't say it's better than IDA, but as a free, it is very good, and it works both on Linux, Windows, and other systems as well. But its debugger is bad. Okay, so till now, its debugger has not evolved enough to match with IDA. That is what I see till now. Down the line, maybe it is still under development. There is debugger feature as well, but down the line, maybe there are more and more improvements. It has debugger, but not as good as IDA. Okay. So only debugger and x64 debugger, they only work with Windows and x86 and x64 versions. Yeah. So these are the different tools. And sometimes you have to choose between OLE debugger and x64 debugger as well. But now I think with the recent updates of x64 debugger, which they released just maybe 2-3 months back, there have been many new features. Okay, so now you can say x64 debugger is as far as OLE debugger. Otherwise, sometimes earlier I was choosing sometimes OLE debugger over 64 debugger due to some reasons. Okay, now x64 debugger is as far as OLE debugger, and it is free of cost, and it is also open source. You can modify its code. OLE debugger doesn't have any. It's not open source. You don't have code. So 64 debugger has many plugins are there. Okay. So another thing is, while using tools, sometimes it's also important that you should use the features of one tool to find out something, and what you find, it can be an input for another tool. Okay, so not necessary that you use only one individual tool. So since you are a beginner, I would recommend you to say, suppose if you get a executable, try to apply all the tools on that executable, open that executable and see how the output of the tools look like. So your executable is not going to change with different tools, but how you see the tools look different from each other. Okay, so now we would be looking into all the three tools, at least a glimpse of this, and DN-Spy tool as well. Okay, so these are quick comparison. So which I talked about. Okay, so now we are going to uh, get into some more stuff. Okay, so another thing I wanted to mention. So there are different instruction set basically. Okay, so other than these are the different instructions. So uh, I would recommend that if you are going for reverse engineering, so you should choose one operating system. Okay, so you cannot. It will take time to master all the operating system. Okay, so either choose Windows or Linux, or initially, if you have enough time, then you can choose any of them. But good to start with Windows, because Windows has the highest number of malware till now. Okay, it's the widely used operating system. Malware is highly targeted. Okay, so and it's used in corporates as well. So maybe 95 to 98% of malwares still belong to Windows. Rest all are less. Okay, so you will next the amount of malwares you will see in Linux, and Mac is once in a while. That is maybe one or two malware families once in a quarter or so. Okay. Windows has the highest, and most of the samples you get from Malware Bazaar would be from Windows. So after that, before getting through the debugger and disassembler, very important to learn to read disassembly. So even though that is not in the scope, but I was because that takes time to learn x86, x64 instructions. It takes a bit of time. But I would suggest you before learning the tools and using the tools, uh, please learn all this properly, because sometimes tools have the features like the compiler, which may not work because of obfuscation and other things. So this is what I talked about. I believe I don't need to talk about it again. So the same thing. And apart from that, there are executables majorly can be of two types. One are the uh, EXEs, which can directly run. Others are the DLLs. In Windows, they are in Windows we'll call those DLLs. So the libraries will call DLLs. So again, how to analyze the DLLs in a tool would be different from how to analyze EXE in a tool. Okay. For an example, if you want to analyze a DLL using OLE debugger or x64 debugger, sometimes they have a loader to analyze the DLL, but in DLL you have to choose the export, um, or sometimes you have to combine with run DLL 32 to analyze that DLL. If you load a DLL in x64 debugger, it works because it has a loader as well. But yeah, you have to choose which export to execute. Okay, so uh, I don't want to get into this one. Okay, so this we already did. Yeah, so now we would be looking into a bit of the some of the samples. Okay, what is the use of these tools? So I've chosen some different binaries here. Okay. So different kind of binaries are here. So one is TCC compiler. So it cannot be used to create malware. So it's almost useless. I've just used as a reference. Next is VC++ based compilers. Next is something compiled directly with SMD, something compiled with VB. One with Delphi. Delphi is another programming language for Windows, which is used to create malware, and .NET. Now, if you see, the highest prevalence of malwares is .NET malwares and VC++ based malwares. And you see occasionally Golang and Rust is rare as of now. Maybe they will grow with time. So what are the challenges? I'll tell you uh, when a new programming language is invented and malwares are developed using that. So basically, when .NET came into .NET malwares came into the picture, so very few .NET tools were there. Okay, so first of all, .NET uh, .NET debugging was a headache. Yeah, so you did not have tools. Then .NET, it cannot be analyzed with the traditional tools like IDA Pro and x64 debugger. So there was not much choice. Yeah, so if .NET was packed, it was very hard to reverse engineer. You have to rely on your dynamic analysis or techniques like memory scanning to detect the malware. Similarly, uh, Delphi also has different challenges. Okay, so directly, even though if you can debug this with IDA, so it's very hard to recognize certain code. VB also has the same problem. Okay, so VB, Delphi, your Golang, they can be debugged in all of these tools like IDA Pro, OLE debugger, and other tools, okay, which we discussed, which are support native languages. But the problem here is you cannot debug. You can debug them, but you very hard to make out code. Okay, so they would require some extra plugins. For Golang, you would require some extra plugin. For VB, you would require some extra plugin. Okay, so that is you don't require a separate tool. Okay, so but to debug it, you require uh, some extra plugins. Apart from that, VB has a separate decompiler as well. So you can take help of that decompiler and work with the help of OLE debugger. Okay. Uh, so let us see. Okay. So let us see these tools. So how to make out these tools, how to figure out these tools. Okay, so there are different automatic tools that will figure out what kind of programming languages has been used. For an example, if I use this, so basically again it depends upon uh, does the tool have any signature for all these compilers or not. So let me open this with TCC. If I open TCC, unfortunately, it doesn't have any signature here. Okay. IDA also does not have signature for TCC, but if you remember when I checked the TCC file with the tool name at treat, so it was able to recognize it. So in this case, TCC doesn't have a signature in PID, okay, so it cannot recognize. VC++, if I open, it says Visual C++ 8. Okay. So again, every compiler has different versions. Okay. So I'll talk about that, how it matters. Okay. So see, from here I'm telling reverse engineering how big field it is. Okay. Malware analysis how big field it is, because there are diversities in the binaries. There are different kinds of programming languages which are used to create malware. Okay, so it really takes a long time to do reverse engineering, and it is completely evolving subject. It's not like okay, you do a 2 day class and it is over, or 4 day class it's over. It's not like that. It's a continuously research subject, because people are required to develop tools to analyze these different binaries, different kind of malwares as well. So now if I open this another VC++, let me see what it says. So here also VC++8 it says. Okay. So next, if I analyze the VB, what it says is Microsoft Visual Basic 5. Okay. If I open the Delphi, so VB Delphi, you have a separate compiler as well. You can use them together with OLE debugger, then only it will work. It says Delphi, and if I open .NET, it looks like this. Okay, so this is the .NET binary. Okay, so it will say. So how does it distinguish each from each other? Okay, so for an example, if I use .NET, one of the significant of .NET is, if you look into the import directory, there is a DLL name as msquery.dll. So which imports API known as query exe main. So this is an indication of .NET. Okay, so that means you cannot analyze this with any of these tools. So let me show you just opening how it looks like. Okay, so .NET, if I open, okay, so it did not, it creates some confusing result. Okay, so it won't be, it executed, but nothing, nothing really worked. Okay, so it's hard. There is no entry point. It did not reach the entry point and all that. Okay, so it would be very hard here. Okay, so for .NET we would require another tool, DNSpy. Okay, so what is the indication of Delphi? So Delphi you can identify with the help of section names. Okay, so basically if I go to the section headers, Delphi has uh, these many sections, almost 8 sections. This many sections are code data, BSS, iData, TLS, iData, relog. Okay, if you see this many sections, it's a good indication of Delphi. After that, if you see the strings also in the binary using text, you will see strings like Delphi. Okay. Similarly, VB has something around the entry point. Its entry point will look somewhat like open this. So VB, when I reach the entry point, I talked about the entry point. Entry point signature looks like this. There would be a push. Okay, so this is something known as Visual Basic Header, and after that there is something like this. Okay, so how does this? How do the compiler vary from each other, and what is the code inserted by the compiler? We'll look into that. So if you remember yesterday, I created a very simple code, hello world. Okay, so hello world I created, and let us see how that hello world looks like when I open it. So I have coded the, I have basically created a hello world C program and compiled with CP plus C++. So let me open this. So this is my hello world, which was compiled just with TCC. Okay. So if you see here, I'm at the entry point. I'm at the entry point, and I don't. I have nothing but it should be a printf or hello world. Okay. But what I see is I don't see anywhere down nearby that there is something related to printf. Okay. So basically, if I go down, scroll, and get into this function, okay, so there is, so you need to know about this. This is means a function call. Call indicates function call. So basically, if I get into this, you will see a call to printf. What does this mean? So basically, what happens when you compile a binary? I'm talking generally about C++ binary. So what happens is uh, you write one code for yourself, main code. Okay. So this is something created by the programmer, hacker, whatever you call. Okay. But the compiler, inserts some extra codes here. Okay. So we'll call that as compiler stub. So this compiler stub is inserted between the entry points. So this is your entry point. So when you start your sample in the debugger or you execute your sample, you are at the entry point. So somewhat between the entry point and the executable, there, between the main, there is the compiler stub. I'll call this as compiler stub. So this is inserted by every compiler. So what is the challenge here? So different compilers insert different kind of compiler stub. In case of PC++, it inserted the compiler stub that looks like this. So maybe there are different versions of TC++ where the compiler stub would be different from each other. VC++ also will insert certain compiler stuff. So what is the problem with this? So this is something we won't like to analyze. Why? Because this is a compiler stub. It will always be clean. It should not have malicious code. Okay, because this is common whether it is common for a malware as well as a clean binary created by the compiler. Okay, so if a malware author creates a malware using Visual C++ 8, at the same time, another person who is doing a general programmer who uses the same compiler, the same version of the compiler, Visual C++ 8, he also will compile, and this would be the common code. Okay, so now as a malware analyst or a signature writer, if you write signature around the entry point, you will end up nothing but into a false positive. Okay, so where you are, and also you would end up wasting if you analyze this part of code. So you need to know, so how to locate this main program in different compilers. So this is another thing. So this is another kind of diversity. So with new binaries, new compilers coming in, you need to do research on this also. Okay, so somebody asked about only detecting with bytes. No, that's not sufficient. You will end up many false positives. These also you need to take into consideration. Okay, so basically, if you see here, C++ in case of TC++, how am I jumping to the entry point? Okay, so let me start my binary, and how am I jumping to my entry point? Let us see. Okay, so I'm at my entry point now. So this is the entry point. Okay, entry point shortcut is EP, and this is the compiler stub. Okay, so whether I create a malware out using TC++, this TCC compiler, or I create a clean file. So this is going to be the same. You'll see the same pattern. Okay. So how do I see the pattern? So in case of TC++, okay, sorry, TCC, so you will see that this kind of patterns will always be there. You need to, obviously, you need to learn a bit about assembly and your APIs. So after that, you will see that there is a call to control FP. There is a set app type API, and after that there would be a get main args, and after that get main args there is a call. Okay, call here, call to a function here, and if I get into this function, I see my actual code. So this is something which I need to analyze. So in my case, it is a clean. But if a malware was there compiled with TCC, then the malicious code which is written by the hacker should have started here rather than the entry point. Okay. So here your IDA comes into the picture. Unfortunately, IDA doesn't have signature for TCC compiler because it is not a standard compiler. It has many bugs. Just for learning purpose, it is fine. So IDA has all these features. Okay, so let me open another VC++ binary. Okay, so there is a VC++ binary. Okay. So if I open this VC++ binary and go to the entry point, it looks like this. Okay, it looks like this. Okay, so this is something, again, the compiler inserted code. So let us see how IDA can help us here. Okay, so let me open this binary. I've not checked it, honestly speaking. Okay, so I was just whether I've updated this or not. So I'm using 3 BC++, right? So let me open this in IDA. So IDA takes a bit of time. Okay, so if you see here, IDA is taking IDA. I think it is still analyzing. It landed me to this position. Okay, and uh, in my uh, same binary I've opened with x64 debugger, I have landed here 489986. Okay, but IDA has landed me here. So what I can do is, so this is the main code. Okay, so this is not the entry point. This is the main function. Okay, so main function is the one which I would be concerned as a malware analyst. Okay, so not the other function. If you see here, you can see here the main. What I can do is I can take a note of this from IDA. Okay, so I can use the IDA debugger also. IDA has a debugger feature. Okay, and I can go here, and this is somewhere I would be interested in. So you can see is related to this. Okay, like it is getting special folder path, it is getting temporary path. Okay, it is doing some stuff here, right? It is opening the reg key. So these are something, when I would have analyzed this binary in dynamic analysis, I would have seen all the things related to this one, registry creation and all. I would have done API logging, I would have seen these APIs. Okay, so all these uh, these are something malicious. Okay, rather than the something the compiler inserted stuff. Now the IDA analysis has finished. Now it looks like this. Okay, so you don't have the addresses here. So by default, IDA hides the addresses. So if you want to see the addresses, what you can do is go to options, general, options. You need to click on options, general, and click on line fixes. So you see the addresses here. You can copy this address using x64 debugger. But before this, very important to disable one of the features in the binary. That is, you need to go to optional header, go to subsystem. Okay, oh, sorry, go to DLL characteristics here. There is something known as DLL con move. Okay, make sure that is unchecked. Okay, it should not be checked. Okay, so in this, your addresses will align, because if this is enabled, there is something known as Windows ASLR feature. Okay, address space randomization. Okay, so it is going to always load the binary in different places. Okay, so as of now, we are doing static analysis of the binary in IDA and dynamic analysis in uh, x64 debugger, dynamic debugging. Okay, so that I would say not dynamic analysis, rather dynamic debugging. Okay, so here I am doing the static disassembly. Sorry, I would be using the term static disassembly in IDA. Okay, so here debugger is yet not running. Okay, so there is no process for this when I'm looking into IDA. And in x64 debugger, it is the process which is created. You can see the PID also here. So it is a process created. I'm debugging here. So by default, problem with x64 debugger is by default they start debugging itself. Okay, so it sometimes creates problem with IDA and uh, only debugger. So whenever you start a binary here, it automatically executes. So what happens if the binary is corrupt? So you cannot analyze in x64 debugger or only debugger. Okay, so sometimes what happens is while unpacking, sometimes we take memory dumps, extract memory dumps. So those would be corrupted files, but we require to analyze them. So in that case, your x64 debugger, only debugger won't work. IDA and Gidra is going to help you there because they can deal with corrupt binaries because they don't launch the debugger by default. Okay. So there is an option in IDA to launch the debugger also. Again, it is free. Okay, so IDA's debugger option is free. Okay, but kernel debugging is not free again. Okay, so some of the compiler is free in this version which I am showing. Okay. So, but it's cloud based, so many organizations might not allow it. So, how to start debugging in IDA? So, need to set up breakpoint by pressing F2, uh, and after that, you need to start the debugger. Okay. So, you have to start it in debugger mode. Okay. So, then only it will work. So, basically, here I told how to so I set up breakpoint. Now I can debug. So, basically, here IDA shows you. Okay, so IDA shows you like this. So IDA has very good decompiler. This would be connected to cloud. Okay, so it told me already. Do you want to connect to the cloud decompiler? Okay, so it says decompilation functionality is provided by decompiler plugin. Okay, we call this generally call it as Hextrace plugin. Okay, Hextrace plugin is there. Okay, it says it is a separate product. Okay, as I told. Okay, your copy of decompiler has limited functionality, namely batch decompilation is disabled. It's cloud based. It notified me because it would be sending the data to the cloud, okay, which organization might not allow. The professional version come without any of this limitation. It supports more processor as well. Processor means different computer architecture or your loaders. Okay, so okay, I want to decompile it. Uh, Let us see. So it decompiles. Here is the output of this one. Okay, so you can see here the source code like this. Okay, so everything we are seeing here. Okay, but see how the decompiler looks like here. You are able to see the APIs very clearly, all the things very clearly. Okay, but if you also okay, so also uh, your x64 decompiler also comes has also a decompiler. Okay, so the let us see how the decompiler looks like. So its decompiler comes as a plugin known as Snowman plugin. So you need to select something, and after that, right click. So my Snowman plugin has been integrated. If I decompile here, so it will show. Okay, but if you see here, it's not so good. Okay, so it's not so good. Some of the things might not be so proper. Okay, so it's not good as IDA, okay, or Gitra. So that is one demerit. So even though you can debug here, problem is your its decompiler is not so good, and sometimes it requires decompiler to analyze the code in faster. Okay, so now we have to. So if I talk about now, so we have to eliminate IDA sometimes the decompiler. So we have to know how to use Gidra. Okay, so Gidra decompiler would be I would be talking about, and I talked about disabling this feature in CFF Explorer. DLL can move option in a executable file. So you can take up the addresses from here, uh, in x64 debugger and see those addresses in Gitra as well. So this you can do. Okay, so this about a quick overview of the tools. So I told about how to use VC++ tools. Now let me show you one of the .NET binaries, how it looks like. So as I told, when I opened a .NET binary in x64 debugger, it's almost useless to me. So let me open with a tool known as dnspy. So I opened this tool with dnspy. So here how it looks like. So you need to understand a bit of .NET about before jumping onto this tool. You have to learn a bit about .NET programming. I don't say that you become a programmer, but I would suggest like learn to read program rather than writing a program. So basically, .NET how it works is .NET is object oriented program. Okay, so basically what happens is there are namespaces like you are seeing here. These are called the namespaces, the curly braces. Inside it, there would be classes are there. So here program is a class. Inside it, there are methods, which looks like this. The box symbol stands for method. Okay, so here is my main method is there, okay, which has the actual code. So I don't do much things here. So it does downloads something from somewhere malware.com, hello.exe, and after that create this registry key. That's it, what it does. And I think it starts calculator also. That's all. Okay, so it is just like reading a program in. If you are used to .NET uh, coding, then this would be easier for you. So you can also debug here. This is problematic. You have to when it comes to sometimes obfuscated code, you have to debug a lot. Okay, so some limitations are there. Okay, so here there is an option for debugging. Like you can start here debugging. It will ask you to click at the entry point. Okay. So it says me I don't have a valid extension because I don't have a I'm not a footer extension. Okay, so I can debug also just like a source code. You can see what's all this happening. Excuse me for a minute. So here my debugger has stopped here. Okay, so I can simply debug here just like I do my .NET program. So I can debug here. Okay, so these are the shortcuts for debugging. Step into step over all these things. Okay, so this is how you use the dnspy tool. So obfuscation, you have to break obfuscation, but only tool left out you without any choice in .NET is the dnspy. You don't have much tools around. There are some things, some tools that will help you to unpack, but not always. Okay, so .NET creates another problem. Similarly, Golang also has some problems, but you can use those with x64 debugger. But you have to use some other plugins along with those. Okay, so now another thing we are going to combine is we talked about dynamic analysis and API logging yesterday. So how do you combine with that with reverse engineering? Uh, then we are going for the Githra debugger. Okay. So I've shared some videos with Githra decompiler. So please take those from Vikas sir. So let us see how we can use uh, use API logging along with the debugger. Okay, so how to use the information generated by API logging uh, with the debugger. Okay, so here I am going to use my logging tool, that is Malware API logger. You can also use the Xlogger tool, and parallelly I would be using x64 debugger. So let us see how this information can be used. So in this case, what I'm going to do is just a minute. So here I would be testing test sample pack.exe with xlogger. Okay, so I'm directly using the pack sample here. Okay, so let me run it and see what is the output. So this is my test sample. Let's see what's out there. There was the previous logs were there. So basically, how can this help me in debugging? I would say. Okay, so basically, if you see here, there are logs generated, and also in for each of the API, I have written like from which address this API has been called. Okay, for an example, talk about this API. It has been it is the return address of this. Return address means the address just after the call. So this will help. Okay, so now what I'm going to do is now this malware I've done dynamic analysis, and it has unpacked also because here it is running under the win malwin API logger. So it has unpacked as well. I would be able to see the strings means API related to the internet communication which was actually there in my source code. I'll see res set values and all those things. And also it is also giving me the addresses from where these APIs has been called. For an example, in this case, res create value is there. Okay. So what I can do is I have started x64 debugger in admin mode, and after that I'll attach a sample here. Okay, and now I've reached here. Okay, so this is a running process which is already unpacked. So what I can do is I can go to that particular address. It is telling. Okay, so I've chosen this address as I showed. So this is the address. Reg create ex value return address. Return address means the before this address there would be a API call. So let us see this. So if you can see here, so before this address there is the API call. So reg create key was being called here. So the API after this is logged. Okay. So basically this in this case I am able to see the unpacked code as well. I can see what else code is also here. Okay. So basically these are all the APIs being called. So I've reached here in this case and I can analyze it. Okay. So this is one scenario where it is hard to debug or unpack. So in this case, you can take help of my tool. Okay, but what is the other way around? Okay, so other way around is basically I know from the logs what's happening in the binary. So now what I'm going to do is start the binary here, start my test sample, and here what I'm going to do is I'm going to use the input from here. Okay, so see this. If you go till here, let us see what happens. Go to this address. What happens? If you see here, this address nothing is there, zero. Okay, so if you see here how we are seeing this is disassembly of zero, means no data is here. Okay, so you cannot see here. Why? Because this sample was packed and during execution data was written here which we were seeing. Okay, so that is why when I attached the debugger saw here I was able to see, but now I'm starting this sample and there is nothing there. So how do I do it? So one way is I can use these addresses, but actual way is to start from the very beginning. I can set breakpoint in all these addresses and go step by step. Okay, so I can see, you can see these addresses. So these addresses are most likely to be present. It has the address just before get proc address. So if you see here, so there would be a call to most likely call to get proc address. Okay, so this would be there. You see here, you can see here it is calling get proc address. Okay, so if you go on debugging, you will reach, you would be able to unpack. Okay, but here what you can do is you can use a shortcut also here. Let me tell you. Okay, let me pick up this one, Internet OpenW. Let me see if it has been decrypted or not. Okay, so okay, it has been already decrypted in this case when I have executed till this point. Okay, so what I can do is I can now set a breakpoint here. Okay, so this is yet to be executed. It has not executed. Okay, in the previous state it has already executed, so I cannot debug from the beginning. So here, if I hit, I would be able to hit here, and from there onwards, I can debug. Okay, so I can debug onwards from there. So this tool you can use along with here, as I showed, API logging you can use as an input, and all these addresses and APIs you can uh, do the debugging. Okay, so you can get the addresses of the API. Okay, so just before this, you can say it is checking the debugger. The instruction before this This firmware API is called. Okay, so you can set, so you know how your binary is working. You can set breakpoint, go on setting breakpoint on the API if you are a beginner. Okay, so after some time you might not be required to do many things, but you can follow this and set breakpoints accordingly, remove breakpoints accordingly, and unpack a binary, deal with packed and unpacked binary, all the things. Okay. Just excuse me for a few minutes. I'll be back. Yes. So next, this is how we would be dealing with um, how to debug certain binaries. Now we would be switching to Gitra. Okay. So for give me a moment. I'll just put some samples. Give me a moment. I'm just doing my settings. Okay. So this time I'm not taking a packed binary for Gitra. Rather, I would use the direct binary. Okay. So I won't be dealing with the packed ones. Okay. So basically, here is my test sample. This is a simple C code which I showed to you guys yesterday. Okay, so this has been composed with VC++, and here is the source code. Okay, and we are going to derive near the source code, not the source code, but near the source code with the help of Gitra. Okay, so basically for Gitra, you are required to install Java, okay, JVM and JDK. Then only it will work. You need to check the latest version of Gitra, what all it requires. Based on that, you need to install. And after that, when you start, so this is how Gitra, when you start raw, it looks like. Okay, so I am starting from the very beginning. I Gitra folder. I'll show you how it looks like. So this is my Gitra folder. Gitra 11.11 is there. Okay. So Gitra has, so we are going to call it as Gitra home folder. Inside it, Gitra.run is there. Before, if you double click it, it is going to execute and it is going to start this binary. Okay. So I have shared a YouTube tutorial with Vikas sir. You can take that from here. So basically all those I have explained here. So you can start with this. This one is most likely for Linux. Okay. So in this Gitra, there are many subfolders are there. You can see here, Hydra is there. Okay, under this, there is features and then base and Githra script. So this is the location where you can place all the Githra scripts which are publicly available. Okay, so you can install the scripts here. So you can tell it like Githra home, and after that, it would be referred to as Githra home, and after that, it will ask you to locate at this location. Okay, so this is the Githra home. It would be, you need to place the script in this folder. So scripts have two versions. One is the Python version and one is the x64. Sorry, one is the Python version and another is the Java version. So this is the main folder, one of the important folder in Githra. So if you want to add script to Githra, so this is one of the places. Okay, so you can launch Githra, but if you try to launch it, if in case Java JVM, your JVM JDK is not installed, it will throw some error. Accordingly, you need to install it. Okay. So now this is my raw Githra, bare Githra with no nothing there. Okay. So basically, in order to start Githra to analyze a file, the first thing I need to do is I need to start a project here. So what I can do is I can go to the menu, click on file, and go to the new project. And after that, it's taking a bit of time. Okay, so it started. You can do with non-shared project, and after that, it will ask you which folder do you want to place into. So it will place the all the information, all the project here, so this location, and I'll put name as malware analysis. Okay, I put here, and project is created here. Okay, so you'll see a project name here. It's taking a bit of time. Okay, so malware analysis project UBC. Okay, so you can create folders and all. After that, what you can do in the project, you can analyze a binary here. So what I do is I import my binary here. Okay, so I go to file menu and go to import. So I go to this location, open this test sample. Okay, so as I told, it recognized the file format. Okay, so this is the file format. Okay, which is recognized by the Githra loader. And here, if you see, there are other also, like it will recognize that a raw binary, other things. There are other things as well. Other than that, language, your computer architecture, it will ask you. So this many languages it supports, C programming and all. Okay, so all it asks 32-bit, 64-bit, little endian. It recognizes some stuff in binary, and you can see all the things. See, any tool I would suggest, like explore, click the buttons and see what all things are there. Okay, so that is the only way to learn the tool, because many things are not documented, hard to write down each of the documentation. Also, any tool you get, process explorer, process hacker, or your procmon, just see the buttons, try to do the buttons. Okay, so that is the right way of learning. Okay, so I click on okay, and after that it is importing the file. It takes a while because Githra does a lot of analysis, so it is doing all this stuff. So as of now I am doing with the working on a dummy sample. Okay, so after this we are going to work on a ransomware and show how it looks like. Again I need to double click. Taking a little while. Okay. So now your code browser is starting here. Okay. It will ask you to analyze, do yes for the first time. And also it will give you this option in analysis. So choose here in case of Windows binary. Windows P propagate. Okay, so it tells you analyzer uses external Windows function called parameter information to populate the comments. Okay. So this would be helpful when you analyze Windows binary. Okay, so it takes a while to analyze. So rest of the files I'll show in my another Ghidra instance. So it takes a bit of time. You have to wait, be patient with this. I'll start from the very basic one. Okay, so from the font setting itself. So you can see here this. Okay, so there are different windows here. So first window is the listing. Listing means your disassembly window is there. Okay, so we call this as a listing window. Other windows are by default. There is console window is there. The compiler window is there. Okay, so this can so there these windows are also available. Other than this, there are some extra windows which might pop up at different instances. Okay, so in case if you find a window missing, you can go to the window tab and after that click on these. Okay, so for an example, there's a console window, it's already there. There's a functions window. Okay, so it will show you list of all functions in Gitra. So you can see here the list of all the functions in Gitra. Okay, so what different function it is here. There is a strings window as well. So define strings, the strings window as well. Okay, so it's still processing is there. Otherwise, you cannot see all the strings and functions. Some basic till it does the analysis, we'll do some basic semantics. You can see our fonts are not that great, so sometimes for visualizing those I can do some font changes also. I can go to edit tool options. Okay, uh, okay, so in this there is a listing display. Listing display refers to my disassembly listing. Okay, here I can increase the font. I keep it generally in between 16 to 20 for a better view. So I keep it 18 here. Okay. So if I apply here, you can see my listing would be enlarged. You see the fonts as larger. Okay. The compiler window also I'll keep make the fonts a bit bigger. So if I scroll down here, it will show me the options. The compiler 18, apply here. I applied. Okay, so there is another options here which is very important. Okay, so that is listing fields. So what is the importance of this? I'll tell you. Let me just close this. Still analysis is going on, so taking a bit of time. So the listing depth, basically I'll give you an overview rather than wasting time here. It takes a long time to analyze. Okay. So in listing fields, there is an option here, cursor text highlight. Okay. So in this, by default, there is middle. Okay. So it says mouse button to activate, that is middle. You need to change it and make it left. And after that, apply it. What is the importance of this? So basically, if there are some similar stuff here, if I click, it will click on different. So if you can see here, if I clicked on push, all the pushes are being highlighted with yellow color. Okay. So what is the importance of this? So when you are reading some code, if you want to locate one variable, say suppose if you want to say where is the BL being used. Okay, so if you click here, you'll see where BL is being used. So BL is used being previously here. Okay, so if I want to know where BL was previously changed, where it was updated last in the instruction, it is here. Okay. Similarly, in the decompiler also, it is useful for reading the. Okay. Now we'll explore a bit about Windows. Various Windows is there. So another thing, like here again the same problem. Your basically we are here at the entry point by default. Okay, but we don't want to analyze. Okay, so you can use IDA Pro to find out which is the main function, and after that locate which is the main function, and after that what you can do is uh, you can use the addresses here. Okay, so let me show you. Okay, so it shows me this is the address where my main code is there. Okay, so I can go there in Hydra and start the read the code from there. Okay, so this is my main function. Okay, so basically this is somewhere I can start reading the code. So one important thing, when you read the code, so this is a assembly code, right? So let me look into the decompiler. Let me look into the decompiler. This how the code looks like. Okay, so this is very near to my source code, right? So I from IDA came to know what is my main function. Okay, so there is another important thing whenever you use decompilers, use labeling. Okay, so as of now, these, okay, so any tool, they generate certain symbols for the binary, okay, certain names for the binary. Say suppose Hydra recognizes these functions and names these are functions and it names the function like this. Okay, IDA, if you see, it would be naming the functions like this one, sub underscore. Okay, sub underscore addresses you can see. Okay, sub underscore addresses you can see. Okay. But Githera names it like this one. Okay. So what is the problem with this? So if you remember, when we do coding, programming, we are asked to follow certain standards. Like whatever is the use, we should name the variables properly. We should name the functions properly. Okay, then only it makes better sense. Otherwise, it's very hard to analyze it. Same thing we follow in decompilation also. Okay, so or debugging as well. So we will call this as, okay. So we'll give proper labeling to whichever code we analyze. Okay, so this is the code. So let me label it as, still you see Gidra has not finished analyzing it. It takes a long time. Okay, maybe 10-15. Uh, and after that, I'm running in VM. It will take a little more time. Okay. So labeling, the shortcut is L. It is not rename the variable. So it will, it is, uh, my decompilation is still busy. That's why it's taking a bit of time. Let me close IDA. Okay, so I'll tell few more things here till it is over. So better to label all these things. Okay, so still it is taking a bit of time. Okay, so if you see here, my functions are here. Apart from that, there are many variables here. Okay, so if you see here in the code, the compiled code, there are many variables here. Okay, do this, do this. So as per analysis, you have to label this. Okay, for an example, here if I figure out that this function is doing something, like say suppose this is printf. Okay, I assume that this is printf. Okay, so you can label this as printf. Okay, function label it as printf. Okay, so it's taking a bit of time, so I'm just avoiding this here. So you can see here, uh, you have to label all the variables and all the functions properly, then only it will be better. Okay, so I'll show in the other. Okay, so now analysis is over. So now let me label this as, now I can label. Okay, so analysis is over. I will label this as main. Okay, so this, my main has been labeled. Now it looks like this. Okay, so main has been labeled here. Similarly, if you see here, create mutex object is here, and after that something has been written. Okay, so there is some function here. What is this doing? Okay, so maybe most likely this is, maybe as far as I know, this may be related to somewhat my printf or something like that. Okay, so now I am here, so I can go back also here, like navigation, go to previous function. Okay, previous history function. If I go here, it will take me back here. So I can look into this and see what it is based on the functionality. Okay, hello world is there, all those things are there. So another thing, if you see here, uh, this is the decompiled binary, and if I see here, this many functions are there. Okay, means 1,111. Okay. And if I see my actual code, this was my source code. How many functions are here? Hardly maybe 8 to 10 functions are there. Where did rest come from? Okay, so rest may be inserted by the compiler. So even if I filter it, okay, so there are certain functions which are related to which are maybe APIs and other things. Okay, so you can see here APIs and other things are also here. Okay, so still if I function just you know, limit to only functions. Okay, still with me some 600 functions are left out with me. Okay, so how do we find important, which one are important, which one to analyze, which one not to analyze? This is the biggest challenge here, the compilation, right? So how do you know? Okay, so one thing is, here we are going to use our knowledge of the strings. Okay, so whenever we do dynamic analysis or some analysis and we come to know about the important strings, we need to use the strings knowledge. Another knowledge we are going to use is the API knowledge. We are going to only look into those functions where there can be important functions, important strings, and where then there can be important APIs. Okay, like what are the important APIs? For an example, something related to network connection. Those are the important APIs which malwares might create. Some APIs related to registry creation. Those APIs might be the important function. Okay, I told about another things like the strings. So there are strings related to a keylogger. There are strings related to stealers. Like in stealers, you will see strings related to browser. There are strings related to ransomwares. I also discussed about that. Okay, so which are the important ones? Okay, so another things I talked about the persistence. Okay, so here I have the persistence strings. So this is the list of strings. Almost there are 562 strings are there. So I can filter out the strings like run. Okay, so this is my persistence string. So similarly, there are many other strings. You will come to know only after analyzing a lot of malwares. You should know the families and objective of malwares. You should know about various techniques of malware, and then only you will come to know about the APIs and the strings. Okay, so here if you see here, I click here and I filter the strings, and after that I click here, double click here, and it takes me in the listing window till here. Okay, so now my objective here is to find out which function is using this particular string. Okay, that is the function that is responsible for resistance. When I filter this string, so it takes me to this location. Okay, so it takes me to this location here, and in this location it tells me X reference. Okay, so not necessarily all the strings would be having X reference, because sometimes some of the things would be connected during the runtime. Some strings would be referred at runtime or during when the code executes. Okay, not statically. So right now we are doing static analysis. So this is the meaning of X reference. X reference refers to reference. So if you see here, the string is being referred at this particular function at this location. Okay. So now if I double click here, it is going to take me to this function. Okay. Now if I look into the decompiler tab, in case decompiler tab is not open, you can go to the window and go to the decompiler. You can see here the decompiler window is here. Okay. So now your decompiler window is here, and you can see inside this function your decompilation is happening. Okay, so you can see the source code line. source code kind of thing. Okay, not exact source code. Reg create key, reg set values. Okay, so but I cannot figure out uh, means many of the variable names are still not proper. Okay, so I would be never able to derive the actual variable name which was used, but I will give a meaningful name for too many of the variables. Okay, so again, if I scroll up here, my function name is something like fun underscore. So I would rather prefer to name it as something like persistence. I click on L for labeling, okay, and I put as persistence. Okay, so this gives me a better meaning. So now the persistence. Okay, so now it has been. Okay. So now there are many variables here uh, which have which don't have proper variable name. Okay, so how to name this? So one way, shortcut way, is to start with the API names, pick up the API, and see which variables are properly not named. Okay, so if I click here, get module handle W, and let me search in Microsoft website itself. What does it? What it does? Okay, so if you see here, one is the H module, next is the H file name, third is the size. Okay, so if you see here, my middle variable, okay, doesn't have any proper name. It says some local variable because Ghidra was able to name it like that. Okay. So in binary, basically, okay, so there are two things. One is symbols and another is strings. Strings are something that is already in the binary, and opening it in any tool doesn't matter. But there are symbols. Symbols are the variables which are named by the tool. Okay, in this case, this is the symbol. Okay, this is not a string. Okay, this is not a string, this is the symbol, while this is a string because this is there in the actual binary. Okay, so these are all symbols. Okay, these are all symbols. Okay, because this is generated by the compiler after by Ghidra tool after it does some analysis. These are all symbols. Okay, these are all symbols which you can label. Okay, so here, if you see here, this is my second parameter, and if I want to label it correctly, let me refer back to get module handle. My second parameter is a file name, LP file name, or a pointer to file name. LP stands for long pointer. File name is file name. Okay. So I label it as LP file name. Now labeling looks better. And if I see here, the use of this, it is being used at this place, it is initiated at this place, its number of characters are 260. Here it is LP file name. Further, it is used in this function as well. Okay. So now I have to analyze this function and figure out what the meaning of this and accordingly do rest of the stuff. Similarly, you can do the labeling here also. Like if you see here reg create key, there are certain variables that are not labeled. You can go to the uh, reg create key and after that see which is this variable number and after this name it properly. Like this, you give a proper naming. Okay, so basically when I name this will also come into symbol. Okay, so this is one way we located with the help of string an important function. What is the other way? So here again repeating, we use the strings to identify a important function. So another way, as I mentioned, another way to locate an important string, an important function is the API names. So where to get the API names? API names we are going to get in the symbol window. So I need to click on window and go to symbol references. So it will give me the list of all the APIs. Okay, all the APIs, and APIs are basically labeled by Kithra, so that's why they would be called as symbols. So let me see for MI, if I search for reg create key, am I coming around this or some other function? Okay, so there are, so let me search for the API reg create key and locate that reg create key. Okay, so if I click here, reg create key API is here. If I click here on the right side, symbol references, it will tell which all symbols are referred at which functions. So if you see here, one of the things is function call here and another is data. So I should not be bothered about the data, rather I'll click here, okay, the call. So I click here, again I'm back at the persistence. That means with the API call also back at the persistence. Similarly, I can explore other APIs as well. For an example, if I talk about internet, internet on a connect W or something. I click here, and I am at the function which is has something to do with the internet connection. Okay, so this is how I am can locate the important functions. Okay, so I use the strings, find references to the strings. I use the symbols table to find references to the table, references to the APIs, and then locate the functions which are referring to those APIs. Okay, so this is how I locate important functions, because I cannot analyze some 60 to 100 functions are there. Okay. So you have to have a good knowledge. Again, there is another assumption: this binary is unpacked. I'm looking into the completely unpacked binary, because looking into the packed binary, you won't get all these strings. You won't get anything. So unpacking binary is another another topic in itself. Won't be having scope of here. Okay. So another thing is, there are many other windows here. If you see, for an example, I reach this function. Okay. So how do I? Uh, so I want to know the entire flow of my entire code. Okay. So how all the things are connected, which function called which one, all the relations I want to know. Okay. So I can go to the window. So basically, I would say that I'm reconstructing the code. Okay, so how to do that? So see, one thing here, I'm using IDA to do the thing statically. Okay, so basically, there are different way of reconstructing the tool. You have to use dynamic analysis, debugging, other ways to reconstruct the entire flow. Okay, so basically, to see the flow, okay, so here is one something known as function called trees. So function call trees are here. So you can see here, this is the below is the function call trees. There is something known as incoming. There is something known as outgoing. Outgoing means I'm in this particular function, and what all functions are being called from here. Okay. And if I consider incoming means which function called this. So if I see the drop down, it will show me like this. Okay. So current function, and it was called from main was called from crt common, and it was called from entry point. Okay, so entry point has the compiler stuff, after that it's called the main. So it showed me the entire flow. Okay, similarly outgoing, which all functions are being called from here or indirectly. So after this function is being called. Okay, so these are the sequence in which called it is called, calling internet open w. I click here, it is showing me all these serials. Okay. So who calls, who is what next, like all these things, it will go in sequence. Okay, if you click this, you are going to see the function, browse it, analyze it, label it, analyze it properly. Okay, so another thing, so here sometimes you would find hard to read what's happening here. Okay, so here you can use your knowledge of uh, not knowledge, basically you can use help of chat gpt, but chat gpt has certain condition. You cannot paste every code into chat gpt and expect a better output. Okay, so in this case, but just looking into the decompilation, I can expect some other stuff, like this function is supposed to do something with internet connection. It uses this api. Okay, so do something with the internet connection. Okay, other than that, two things I observe here is function, there's no proper naming. I've not named it. Okay, so when I paste this code in chat gpt, since these two are not labeled correctly, chat gpt might not give you proper output. Okay, so in all cases it might not be reliable. You just copy pasting won't help. Okay, because these functions are unknown to chat gpt, only you after analysis you can come to. So now let me paste this in chat gpt. So you can simple, there is chat gpt plugin also integration in Vitra. Okay, so you can simply tell what it does. Okay, so it will give you some suggestion at least, even though might not be accurate. In some cases, it is completely helpful where pure algorithms are used and not any of the API. Okay, so it guesses, some guesses, may or may not be correct always. Okay, remember, it guesses this function could be here. Okay, again, it depends upon how much data has been to chat GPT and all those things. Okay, it gives you all this explanation. Okay, you can use this information, but again, do not rely. Okay, it is completely, it depends upon your input and depends upon how much knowledge chat GPT. has. Okay, so do not rely unless you analyze. Okay, some cases I've seen good results, some cases it may be uh, deceiving result, incorrect results will be there. Okay. Another thing is graph view. Okay, so if you click here, you'll see how this function looks in a graph. Okay, so you can see graph view of function. This would be like a flow chart. Okay, you can expand it. Okay, expand it like this by using the mouse scroll button. Okay, and after that, read the code, see the flow. So this would be helpful in analysis. Okay, to see the code properly. Okay, so these are some of the key feature. So if you want, sometimes you can arrange the windows also. I would suggest, like, if you want to read the decompilation properly, you should put it beside the function window. Okay, so you can also take it outside. Like for an example, you can click here the decompiler window, take it outside here. Okay, and after that in the functions, if you click on a particular function, you can see the decompiler side by side. Now your decompiler window and function windows lie side by side. You can click here, see the code instantly. It will be with faster analysis. Okay. So this is the strategy of analysis. Okay. So basically, I told about things like how to use the graph view. I told about how to see the code flow using the uh, function call graphs and all. Told you how to use the important functions. Okay, important functions, how to identify using the X reference. Okay, X reference means references. So you need to refer to, first of all, you should have knowledge of strings and the important APIs, and provided the malware is unpacked. Okay, so these are few of the important features. Other features also you can explore here. Okay, uh, so these are the key features I told, and UI also I told. Okay, so now we would be looking. Okay, so another thing. Say suppose if you do labeling and all. Basically, also Hydra has a database, and all the tools have a database. Say what you can do is you can save the database, and after that open it as another Hydra and export it to other tools as well, like X64 debugger or anything. Okay, so certain conditions are there. So for an example, here is an option to export. Export program. So if I want to export it, so let me put it here like this. Okay, so I'm just exporting here. Okay, so it would be saved as a, take some time sometimes. So GZF file. Okay, so this is Gitra database file. So what is the use of this? So basically now you don't require executable to analyze this. You can open this again with Gitra. You can send it to a friend also. So whatever analysis you have done, okay, so whatever analysis you have done in your tool, you can send it to a friend and he can analyze it. Okay. So you don't require to send the actual exe. You can send this as well. Okay, similarly, IDA has IDB file, your x64 debugger had DD32, and these symbols can be imported. So suppose if I, as I told, Gidra doesn't have a good decompiler and all. So you can, sorry, not Gidra, x64 debugger doesn't have a good decompiler. So basically in the decompiler, you can use your knowledge to do the labeling and import this GZF file into x64 debugger. That is also possible. Okay. So this is how you do analysis. uh, Here you, this is the way to combine multiple tools as well. I told how to integrate get the information from IDA and use it in X4 and Gitra. Similarly, you can use Gitra decompiler and integrate and get that information into X64 debugger as well. Okay, so you can use the shortcomings of means the pros of one tool and use that to analyze, and it be able to cover the shortcomings of another tool. Okay, so one thing that is left is okay, I'll show you analysis of a ransomware. Okay, so before this, quickly I'll show you one of the malware. So I won't take much time. So here is a malware. Okay, so basically these are the strings window. If you want to analyze the strings also, you can just uh, copy them. Okay, copy, and after that select columns. In this select columns, I put only the string value. Okay, and after that do OK. I do OK. Look into the strings, what all you can figure out. I'm telling by this. Same thing could have been done with print text as well in this binary. I'm using Ghidra for doing string analysis. Okay. So here, if you see here, so if you see here, there is in string analysis in this binary, you will see certain IP addresses there. One IP address is there, C dollar is there. Okay, something like KNPP administrator is there. So let us search for this and see what happens. Okay, this is already documented malware. So I'm just want to see in case if it is sometimes Google also removes the analysis. So let us see what it leads to. Okay. So basically, if you see, it KKNP refers to uh, Kudankulam nuclear power plant. Okay. So this particular malware was targeted here. Okay. And there was a report. I think it is. Otherwise, it used to come in the page itself. Okay, so there was a malware known as Day-3. It had targeted it. Okay, so this was reported in 2019. Okay, so this was a targeted attack. So how do we figure out some of the things? Like one is this malware was able to compromise. It was got into the organization. There it tried to connect to these IP addresses. Somehow it has knowledge of some of the IP address. C dollar means shared uh, on this IP. Some shared, C share is there. Okay, so your SMB shares are there. From there, it tried to connect, and after that, do some stuff. Okay, so all these information are there. It might try to steal some browser information and all those things. So this was a targeted India attack. You can refer to this. Okay, Cyberbit, the IPT attack is there. You can gain some knowledge about this malware. Okay. Give the sample name also, and after that, it gives some information what it does, all the flow. Okay, everything was given here. So you can refer to this. Okay, so if you get hold of the sample, or I'll sometimes share this one, the gzip file. Uh, I'll share it later. Okay, so it has given the entire code, how it works, and all the things. Okay, this could be something interesting for your research. Okay, so let me now switch to yeah. So this was the important string, and if you want to look into how this string has been used, so basically you can click here, and here if you see this string, it is used in this particular function, and if you see the decompiled function of this, so this is the source code, right? So this is the source code here, and here you will see like how it has been used, right? So you will come to know the entire use. You see, read rest of the code, you will come to know what it does. Okay, so this is how, with the help of the string, how you can do many stuff. Okay, so straight away I picked up the string, found out, located the code, what it does, read the code in the decompiler. Okay, so it takes very less time. Okay, so okay, the problem is now uh, there are many strings here. How to know which functions are important and all the things. So basically, I have written a tool also, which will help you in identifying the strings. Okay, so I'll apply that tool here. So you can find the tool in my GitHub repository. So let me go to the ransomware. Okay, so let me go to the ransomware here, and I'll show the use of that tool. Okay. So here, so I've written a tool known as malware function reconner. Okay. So what it is going to do is it is going to iterate all the functions, show you what APIs and what strings are used in that particular function. Accordingly, you can decide. Okay, so how to? Okay, so give me a moment. So how to use the scripts in Gitra? Okay. Sorry, I did it a bit quickly. So if you hover over this window, okay, so there is a script manager there. Okay. So I'm using it directly on my machine because I'm not running a malware. This is the Gitra GZ files are there. So these are not going to do any damage to my system. They are not going to run. And only the GZ file are there. So here is the script manager. As I told where to put the script, basically you can put the script as variable location. Okay. Uh, here is a script manager. If you click here, and here if you click, it will tell you which all locations you can keep the scripts. Okay, so you need to click here, which is the script manager, and after that click here, it is going to list you the various location. Okay, so one of the location I think I showed you is Ghidra home feature base Ghidra script. Here you can put your Python script. Okay, there are similar locations, but I usually prefer here because many places by default I never try to put any other places. So this is the default location where I put. So after putting the script, it is being reflected here. So basically, you need to refresh when you install a new tool. If you restart entire Ghidra, that's fine. But uh, in case if you instantly put the script and want to see it or edit the script, you can click here on refresh to get the script. Here you can put the filters which script you want to find out. So there are a list of many scripts. My script is here. My script name is Reconner. So I run the script and Ghidra it script or if it is outputting to the it is going to put output to the console you are going to see here, otherwise you can see here as well. Okay. So my code what it does is it puts all the output into a text file and starts it. Okay, so you can see here there are various functions here, and my script also gives you some important stuff, like it will tell you what does the function do. Okay, still now I've not done all the labeling, it takes time. For an example, this function this function is at particular this address, it calls local alloc. And what is local alloc? It's a memory function. Okay, so now at inside this function at this location, this is the function call, API call, string cat w is there. This is a string concatenation function. Okay, so like this I've created. This would be helpful for you in analysis. Here I've used in this function at this address inside this function, there is a function call here. WNet open W is there used for network. Okay, you can verify this. So if I go to this function, let me go here 4014 this address. If I go here, okay, and check here, it will show that this function has been called here WinNet open W. So let me just okay, so this is how it is able to locate. Now coming to ransomware, there are certain strings in ransomware. So okay, so you can browse it here. Like for an example, VSS. Okay, so one of the important strings in ransomware, if it is completely decrypted, unpacked, or anything, one of the important strings in modern ransomware are you might see some strings like VSS admin, BCD edit. Okay, so what is the importance of this string? This string is used for deleting the backups. Okay, so after encrypting the files, malware minds often delete the backup. Okay, so you can see in this particular function, I've already labeled, so it is showing it as backup deletion. That's why it is showing labeled. Otherwise, it would have shown like function underscore this address. Okay, so basically, this function, okay, has the BCD edit at this location. If you see here, so this is the string here. It is being used here. Okay, so it is being referred here. Okay, so it will call other things you are not able to see here. Okay, so it will call this BCD edit all the things. Okay, similarly, say suppose if I want to find out the location where file is getting encrypted. So yesterday I discussed about one of the important APIs, okay, that is crypt encrypt. So if I go here, how do I find which APIs are being called? Okay, so now I need to find the function which is responsible for encrypting the files related to cryptography. Okay. So how I do? So crypt encrypt is one of the Windows APIs responsible for encrypting data, right? So I can go to Windows, go to simple references. Here I search for the API crypt encrypt. Remember, this would be fruitful only if the malware uses this API. Okay, malware if it uses other mechanism, it is not useful. Okay. So basically, I have done some prior analysis, and there are two functions here. So one of the functions, this is one function. Okay, you can see one function is this one, another function is this one, another function is this one. I've done some analysis on this and determined that this is responsible for file encryption. Okay, how do I tell? Because after analyzing the function, this is the file encryption function, and if I open this in decompiler, okay, if you open this in decompiler, so you will see the code flow of the how it has been encrypting. Okay, so remember yesterday I talked about how does it encrypts. It opens a file. After that, checks, usually malwares might check for a certain file size beyond, oh, sorry, ransomware will check for a certain file size. If file size here is beyond below a certain limit, it won't encrypt. After that, open the file. Okay, set file pointer to go to a certain location, read certain amount of buffer from the file, and after that, what it is going to do is these are certain APIs which might be used for copying the data into the memory. After that, crypt gen key means it will generate the key. Crypt export keys for writing the key. After that, crypt encrypt is being called. Okay, it is going to encrypt the buffer which is read. After that, encrypting the buffer, it is going to write to the file using set file pointer and write the file. After that, it destroys the key. So most likely this ransomware, for every file, it generates a new key, looks like that. Okay. And after that, it closes the key. After that, it closes the file. Okay. So this is the flow, and from here I can figure out what it does. Okay. So this is the function related to function encryption. Okay, so if I want to see further functions, let me functions which are calling this. What I can do is I can go to the call uh, function call tree. Here I go to the here I am at this point. Okay, so file encryption is being called from another function, that is call file encryption. Okay, so if I click here, I'm going to see the code here. Okay, so I go here, and after that I go to the decompiler code, and here is what I see. Okay, so it calls function. Similarly, here also I have to see the caller and see how what it does. Okay, so this is the original main function, and if I see here, main function does here. Okay, so does some stuff here, like it is checking for target extension and all. Okay, so how do I identify the target extension function? So if again I can use the strings. So in malware, in ransomware, you'll see a list of extension which the ransomware is going to target. So if you observe here in the strings, there are a number of extensions being listed here. Okay, so I click one of these. When I click here in the listing window, I see here that certain the string and where it is being referred. If I click here, it will take me to the place where it is being referred to. Okay, so I come here, I see where it is being used to. Okay, so it is being listed here, and after that, okay, so I got here, and here the entire code is there for listing. So I can go here and do the decompiled code and see what it does. Okay, so I go into here, and after I see here the code that is responsible for checking the extension. Okay, so ransomware has few functionality. One of the function is file encrypting. One is uh, extension check. Okay, another is deleting backups. Okay, using the knowledge you can connect the code. You can see here how the strings. There are various string comparisons are there. Okay, so I have not labeled it, so it is partially labeled. Okay, so this is about use of Githra. I also told about how to run the scripts. There are many scripts. I have written two, three scripts are there. So in my GitHub repo, I've shared already the GitHub repo with sir. So you can go here. Detection engineering Githra scripts are here. Okay, I often release some other tools also. Please follow my GitHub page, my YouTube channel for updated things. Okay, there are few tools I have written. Like one is malfunction tracer, one is like integrating Githra and x64 debugger. Function reconner is there. Okay, so this will give you decompilation of all the function. Okay, so this one is going to find some jumps and all the things. Okay, this will help you to search certain bytes. Okay, so these are different scripts I've written for Githra. You can follow these. Also learn how to write script that would be helpful in automating some of the stuff. As I showed, like locating which functions are having which APIs and which strings. This kind of automation would be helpful in analyzing the things. Okay, so I think yeah, whatever I have to tell, it's over. Uh, so now we'll wait for the question. So any questions?
So participants, you may put your question. Yes, sir. There are few questions.
Okay, so I think it is from 418. Respected sir, can we focus on the entry point only, or what our focus is detection analysis? As I told, very clearly told, entry point doesn't have the uh, code which is created by the um, malware writer. Okay, so you have to start from the main function, not from the entry point. Okay, what can we get the exact name of encryption algo by attacker? You can get, but you have to do deeper analysis. There, even you have to do analysis like you have to do sometime at assembly level, and there is a tool known as FindCrypt. It will sometimes help you. Okay, so let me show you. Uh, yes, I have this. So always tools might not be helpful. Okay, so let me see. I have this case. So see, I showed with the help of decompilation without disassembly language. Okay, so disassembly is another topic. Okay, so disassembly. Okay, so in this case, I don't see any encryption here. Okay, direct encryption here, where algorithms are being used. So in this case, you cannot see. Otherwise, find crypt tools, if there is some kind of algorithm for which it has patterns, it will recognize. Otherwise, you have to know the fundamentals of encryption. Okay, like how to recognize AES and all. You have to read through all. Okay, so no shortcut. See, this malware analysis subject, malware analysis, and reverse engineering subject, where you have to know more and more subjects. Okay, like for an example, if you want to know about cryptographic analysis, there is also a subject you have to start from the very basics. You have to know patterns like you might have heard in ace encryption, s boxes are there. Okay, so all things are you need to understand more and more things. Networking, many things you need to know. Okay, so it's like reverse way of programming. So you have to understand different libraries, different code, different operating systems. Okay, so it's a big field. It's not a small that you can, as I told, it cannot be completed in a 4-day class or something like that. 4-day class, you'll get an overview, and after that you need to explore all the knowledge, the tips you what you got. So have you worked on Python capstone library? No, I've not worked. Uh, I'd heard, if I worked also, maybe long back, don't remember. Uh, it is a very tedious, Lakshmikant, it's a very tedious task to verify and eliminate the same. It is a very tedious task to verify and eliminate. Lakshmikant, I don't get your question. Is it? Okay, yeah, it takes time. See, reversing depends upon the malware, how big is the malware, how much code it is. I showed you a small function, small program I created. It has 1,000 means 1,111 functions are there. Think about the real malwares which have much codes. I had just 10 functions. Okay, in that how much you see. But here your knowledge, various knowledge are there. So see, there are malware is very diverse in Windows, Linux, many other things. So okay, malware detection. Okay, so we'll talk about malware detection later. Okay, so I'll just quickly show you about the diversity. I have actually this about my training. Okay, just wanted to show you quickly. So this is my portal, somewhat like Udemy. Okay, so this I used to train people. So you see the diversity here. Okay, for an example, cryptography, many kinds of malwares are there. Okay. Networking is one chapter. Packers, code injection. These are the different techniques. Okay, rootkits. These are the different techniques used by malware. Okay, so many programming languages are used. For an example, I'm focusing only on few: Golang, VB, Golang, anti-analysis, and after that, many techniques are there. Okay, like anti-analysis, evasion. All these techniques are here. Okay, there are different kind of malwares are also here. Apart from all these malwares can be written in different programming languages like ransomware, POS. Okay, your stealers are here. Okay, many different kinds of malwares are there. Okay, so basically the diversity is very high. Many anti-analysis techniques are there, anti-VM, anti-debugging. Okay, for anti-debugging also I've written a plugin. You can refer to those. It will be able to identify anti-analysis techniques as well. So basically, malware analysis, the techniques are very much diverse. See, malware analysis has been evolving. I have seen it from 2007. Okay, people have seen it from, uh, you know, The first, I think it was Norton was first. I think the first one. I don't remember exactly the history. Okay, so from there it has been evolving. Okay, think about this. So this parallelly goes on with the new technologies and everything. Okay, you can consider malwares parallelly developed, just like your other things coming into security. Parallelly, it is developing. Okay, so it's a very very vast field. It's a complete separate topic in itself. Okay, I cannot consider this a small part of cybersecurity. It has become a very very big subject. Okay, like you have as many operating systems are there, that many malwares can be created for different operating systems. Depending upon your operating system, different malwares can be created using different techniques, exploiting your operating system. Uh, yes, yeah. So yeah, but this is a commercial one. So I run it separately in university. If somebody is interested, reach me out. Shrikanth, you have this question. Uh, yes, any other questions? Download and check it. Virus total mostly. Yes, virus total will tag it as malware. You cannot do it. So that's why we ask you for VM. So virus total has false positive, right? As I told, many things are false positives. Okay, so it's not necessary that any other tools you use, even IDA might be tagged as false positive. Okay. So virus total initially only I told they can generate false positive, false negative, anything. I hope Rajesh Sharma, I answered your question. So download these tools in your virtual machine. Okay. Anything related to malware analysis tool, run it on virtual machine. I would suggest you that. Any further questions? I hope everybody has got a link to my YouTube channel also, okay, because there are some videos. This Gidra, whatever I taught, I shared with Vikas sir. So there is a complete all these things. Most of the things are there in the video. So I don't think requirement of sharing the slides is there. Also, some of the stuff are in YouTube channel as well. Okay.
Okay, so I think we are done with the questions. I hope this the tools like Litra and its functionalities, how we can use for different files, how we can use the disassembler, decompiler, and so those things. I hope it will be clear to all of us, and mostly this the Git almost similar kind of functionality. So you may also explore IDA additionally if you want. And the thing is, as sir told, you should have developed some kind of this means assembly code knowledge. Then it will be very much helpful for you to analyze your files. So thank you so much, the participants. The next session will be from 6:10 and will be taken by Professor Nim Kubali from IIT Indore. So kindly stay there.